Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about open and closed loop system in control system modeling. So what is control system? So when a number of elements are combined together to form a system to produce a desired output, then the system is referred to as control system. The system control based on output and input signals. Each element connected to the system has its own effect of its output. Because if you are adding more number of elements to the particular controller, then automatically it may be a either closed loop or open loop systems. So here they are given about closed loop and open loop systems. So the values which is used for resistor and inductance and capacitance is in open system. So but here voltage, resistor, inductance, the same value which is connected to the voltage means then it is a closed loop system. So here they are given about some examples. So definitions. So there are some two systems, open loop and closed loop systems. The control systems mainly used for adding more number of elements to the system for getting proper resolution or output of the concerned systems. So here the output can be identified by using a mathematical calculation between the input and output system. Then if it is found any error, then we can able to find the concerned error through the linear control systems. So it is related by some non-linear relationship also. Then the system is called non-linear control systems. So the mainly used for this closed loop and open loop control system is accuracy, sensitivity, noise, stability, bandwidth, speed, and oscillations. So these are some factors which is used for control system applications. Types of control systems: automatic and manual control systems. Nowadays we are using more automatic control systems for human purpose. So especially for car, they are using automatic systems based on the sensor. It can able to work with the based on the speed control systems. So the speed control system has been operated based on the differential calculations. While based on the speed, then the movement of the gear has been moved to first gear, second gear, third gear, like that. It is automatically set based on the control systems. So it can be calculated based on the number of mathematical calculations. And let us see how this calculation has been helpful for this control systems. Open loop control systems. So the desired person input has been given to the controller, then controller output has been given to the process, then we can get the output. So here we are adding only limited number of applications by using this open loop control systems. It is a control action is totally independent of output of the system. Then it is called, it is an open loop control systems. It is a manual control system because we are giving only one kind of information to the system so that we can get the output. So like a manual gear. So practical examples: electric hand dryer, automatic washing machines, bread toasters, because it is a one way of communication. Once if you are turn on the particular operation, then it is working, keep on giving the output to the concerned systems. Bread toaster, once if you are giving the input to the machine, then automatically the bread can be toasted while pressing the machine. Automatically tea coffee maker, it is already settled machine. Once if you are assuming that it is the level of the coffee, so that it can give the machine based on the users. And timer based clock driver, volume on stereo system, so the stereo system also controlled by the manual operations. On disadvantages, it is a simple one, economical, easy to maintain, generally stable, convenience to use as an output. It is a difficult to measure. And the disadvantages is inaccurate, unreliable, and any changes is output cannot be corrected automatically because it's a defaulted one. So we can't even add any kind of things to these controllers. Feedback loop of control systems. The feedback loop is known as closed loop control systems because we are having a large number of input signal in this closed loop system, so that we can get more number of additional devices based on the input. Once if you are having any error occur in that transmission, we can able to predict in the input signal also, or else we can able to remove the concern signal by using these applications. Feedback loop systems, input signals is R, E equal to error signal, and G is a forward path because it is on feedback, so that we can use this forward path. H is a feedback, and C is output signal, and B is feedback signals. So input controller process output feedback. So if it is having any error, then we can able to find it in input signal. Unfortunately, if we won't remove any signals, or the signal is right means, then automatically we can feed to the next controller signal. Then it is going to the output signal. Suppose if it is having any error, then we can able to correct it in input signal. After that, we can able to send the information to the controller. The examples of a closed loop system means automatic electric ion, servo voltage stabilizer, water level controller, in air conditioner, the cooling system in car. So it is a defaulted one because cooling system means we are having a large number of operations or options in the car, so that we can able to control the system by using function as in car. Disadvantages and advantages. Advantage is closed loop control system is more accurate because if it is used in car, once if you are assuming that your car, you need to have a more number of AC, means we can regulate the control button so that we can get more number of AC based on the user's car conditions. Next one is bandwidth large, and automation is also high. The sensitivity of the system also we get more stable one. And the disadvantages are it's the costliest, and it's a very complicated design, required more maintenance. Feedback leads to oscillator response, overall gain is reduced, stability also the major problem, and more care is needed to design a stable closed system. On assessment, in what scenarios is an open and closed loop more suitable in a closed systems? The open loop control system and closed loop control systems, already we have discussed that applications and drawbacks and advantages also. So the listed about some few applications over closed loop systems. Open loop system is a feedback element is absent. The main thing is on feedback is absent, and next one is error directory is not present because we don't know which kind of errors has been generated during the signal transmission. So one of the thing is which is really not present in open loop is error detection, and next one is it's a stable, easy to construct, it is not an economical. So these are some few advantages over closed loop systems. It is inaccurate. The only thing is if you are adding more number of device, it is inaccurate, but closed loop is accurate. And less maintenance is required, it is more required more maintenance. Unreliable, it is reliable. Hard driver t makers, it's a default one. We can add more number of devices like servo voltage stabilizer preparation systems. Thank you.